Okay, right. In this lecture, we'll talk about symmetry of graphs about coordinate axes. And our first case is we want to find the condition our graph is symmetrical about. First case is x-axis. Suppose there is a point P and coordinates of this point are alpha comma and beta, and I take reflection of this particular point about x-axis, which means x-axis is acting as a mirror. Reflection of this point about x-axis is P dash, which means alpha remains same and beta gets converted to minus beta. So these 2 points are symmetrical about, they are at equal distance from x-axis. That's it. Means if 2 points have got same x coordinate and their y coordinate differ by minus sign, which means these 2 points are at equal distance from x-axis. Now if our graph is symmetrical about x-axis, this is the precise situation. In this particular case, this P and P dash will lie on this curve y equals fx, which means if we replace y with minus y and graph function remains y equals fx, which means our graph is symmetrical about x-axis. Like first case is mod y equals x, this line is y equals x and this line is y equals minus x. We will be talking about these graphs later on. Second case is y square equals x. If you replace y with minus y, y square equals x remains same, which means this graph is symmetrical about x-axis. Suppose there is a point, let's say this point is x coordinate is 1 comma 0, likewise this is 1 comma 1 and this is 1 comma minus 1, symmetrical. Now this second case is symmetry about y-axis. Same principle applies here. If P coordinates are alpha beta, reflection of this particular point about y-axis is P dash. Alpha gets converted to minus alpha and beta remains same, which means if 2 y coordinates are equal and their x coordinates differ by minus sign, these 2 points are at equal distance from y-axis. It means if we replace x with minus x and curve remain y equals fx, the graph is symmetrical about y-axis. Like first case is y equals mod x. This line is y equals x, this line y equals minus x, graph is symmetrical about y-axis. Y equals x square. There's no need. Okay, next case is y equals cos of x. Graph is symmetrical about y-axis, and we'll be talking about this. This is just a formality. We'll be talking about these graphs much. This is pi and this is 2 pi, sorry, 2 pi, which means this point at 2 pi we are getting plus 1, and at this point we are getting again at minus 2 pi, we are getting y coordinate is plus 1. Okay, now third case is there is a point P alpha comma beta, and suppose this is our mirror, this line y equals minus x, this is our mirror. In this particular case, P and P dash are a reflection of each other. If this point is alpha comma beta, this is minus alpha comma minus beta, which means this distance and these 2 distance are same, which means if we replace x with minus x, simultaneously y with minus y, and graphs means function remains y equals fx, graph is symmetrical about this line, which in other way we say graph is symmetrical in opposite quadrants, first and third and second and fourth. Like one of the examples is xy equals 1. Why we are getting this shape is we'll be talking about this in later on chapters. Like this is rectangular hyperbola. If there is a point 1 comma 1 will lie on this, likewise minus 1 comma minus will lie. Y equals sin x, and this is the graph is symmetrical like this. Pi by 2 we are getting plus 1, at minus pi by 2 we are getting minus 1, and at pi by 6 if we are getting half, then in minus pi by 6 we are getting minus half. And fourth symmetry is about y equals x line. If point P alpha comma beta, reflection of this about y equals x is beta comma alpha, means if we interchange x and y coordinates, if we replace x with y, simultaneously y with minus y with x, and function remains y equals fx, graph is symmetrical about y equals x. Again, this is one of these cases. Okay, this has got a very beautiful property. If y equals fx, like fx and f inverse x are reflection of each other about y equals x. And again, we'll cover a few good questions on this particular thing when we talk about functions. Now we have discussed 4 symmetry about x coordinate, x axis, y axis in opposite quadrants, and about y equals x. There are few graphs, many graphs which are not symmetrical about any of these. Like one of the cases is fx equals exponential, fx equals e raised power x. Graph is not symmetrical about x axis, not y axis, not in opposite quadrant, not y equals x. Likewise, f of x equals cos inverse x. Graph is not symmetrical about, it's not showing any of these symmetries. Okay, that's it for this lecture.